You know, there's this incredible, invisible force at work all around us. It connects the most ordinary stuff in your house to one of nature's most mind-blowing spectacles. So what is it? Let's dive in.
It seems like a weird question, right? I mean, one is a little thing holding up a pizza menu, and the other is this huge cosmic light show dancing across the sky. But trust me, by the end of this, you'll see they're powered by the exact same fundamental force.
So to understand that connection, we've got to go back to basics. We need to look at what magnetism actually is, this invisible power source that's hiding behind every single magnet.
Okay, so every magnet is surrounded by something called a magnetic field. You can't see it, you can't touch it, but it's definitely there. Think of it like a bubble of influence. And it's a non-contact force, which just means something doesn't have to be physically touching the magnet to feel its pull or push. It just has to get inside that invisible bubble.
And what's really cool is how this field is structured. Every single magnet, doesn't matter if it's a tiny little speck or a giant bar, has two ends, a north pole and a south pole. And those invisible lines of force are always flowing out from the north and looping right back around into the south.
Now, get this, and this part is wild. You can't ever have just one pole. If you take a magnet and snap it right in half, you don't end up with a north piece and a south piece. Nope, you instantly create two brand new, smaller magnets, and each one has its own north and south pole. It's just an unbreakable rule of the universe.
Okay, so we know magnets have poles. But what happens when you bring them close to each other? Well, it all comes down to two really simple but incredibly powerful rules of attraction, and of course, repulsion.
And here they are. It's so simple, it's beautiful. Opposites attract. Bring a north and a south pole together and whoosh, they'll pull towards each other. But like poles repel. If you've ever tried to force two north poles together, you know what I'm talking about. You can literally feel them pushing each other away. It's physics you can feel in your hands.
So here's a key question. How do you know if you're holding a magnetic material, like a paperclip, or an actual magnet? Well, here's the trick. A plain old magnetic material will always be attracted to a magnet. But only another magnet can be pushed away or repelled. That repulsion, that's the ultimate test. It's proof you've got a magnet in your hands.
So that makes you wonder, doesn't it? We know things like paper clips are magnetic, but what about everything else? What kind of materials get to be in this exclusive club, and which ones are left out?
Well, the list of magnetic materials is actually a pretty exclusive club. The big players are iron, steel, which is basically just iron, cobalt, and nickel. But lots of other common metals like copper and aluminum, totally unaffected. And as you'd probably guess, things like wood and plastic, yeah, they're not getting an invitation.
All right, time for a little trivia. The year is 2012. What do you think happened in the UK that year that suddenly changed the magnetic properties of the coins in your pocket? Any guesses?
The answer is the coins themselves changed. See, before 2012, the 5 and 10 pence coins were made from a non-magnetic mix of copper and nickel. But after 2012, to save some money, they were switched to steel with a thin nickel coating. And since steel is mostly iron, presto, the new coins suddenly became magnetic. A simple change in ingredients made all the difference.
So far, we've been talking about fridge magnets and coins, things you can hold. But now, we are going to scale things up. I mean, way up. We're going from the palm of your hand to our entire planet. So yeah, forget about magnets you can hold in your hand. Let's think bigger. Much, much bigger. Because it turns out, the very planet we're standing on is actually one enormous, giant magnet.
So how is that even possible? Well, you have to go deep down into the Earth's core. Down there, there's this massive, churning ocean of molten liquid iron. And remember, iron is on our magnetic list. All that constant motion generates a colossal magnetic field that wraps around our entire planet like a giant invisible shield. And that is exactly why a compass works. The little needle in a compass, it's just a tiny, lightweight magnet. Since it's free to spin, it naturally lines itself up with Earth's huge magnetic field lines. And those lines, well, they point north.
But hold on a second. Remember our #1 rule, opposites attract. So if the north pole of a compass needle is pointing towards our geographic north pole, what does that tell you? It means that, magnetically speaking, the place we call the North Pole is actually a magnetic South Pole. I know, it's a little bit of a brain bender, but it's the only way the physics works out.
So, okay, it's cool that this giant magnetic field helps us navigate, but what's the real point of it? Well, it turns out it's one of the most important things protecting every living thing on this planet. It is literally our cosmic shield.
Here's how it works. The sun is constantly blasting out this stream of charged particles called the solar wind. Our magnetic field deflects most of it, sending it harmlessly out into space. But some of those particles get trapped and are funneled down the magnetic field lines right towards the north and south poles. And when they slam into the gases in our atmosphere, they light up.
And that beautiful, glowing, dancing light show, that's what we call the aurora. It's so much more than just a pretty sight. It is the visible proof that our planet's magnetic shield is working, protecting us 24/7 from a constant storm of solar radiation.
And we've got two names for this amazing spectacle, just depending on where you're standing. In the northern hemisphere, it's the famous aurora borealis, what we call the northern lights. And down in the southern hemisphere, it's the aurora australis, or the southern lights.
And that right there brings us full circle. The very same invisible force, the same basic principle of a magnetic field, is what holds that note to your fridge and what protects our entire planet while creating one of the most breathtaking shows on, or I guess above, Earth. It really is all connected.
It really makes you think, doesn't it? Magnetism is just one of these hidden forces all around us. What other unseen powers are quietly shaping the world you're living in every single day? Something to think about. Thanks for tuning in.